Hello everyone, it's Mike Levin on Wednesday, August 10th, 2022. Here I am on my Windows system, and I am on screen 4 of 7 virtual desktops. So I like to use these virtual desktops, and I put very typical things in screen 1, screen 2, and screen 3. But then starting from screen 4, I have it fairly open-ended for apps. Now, I'm running nothing right now, so it would appear. Now, what I'm going to do is show you that I'm actually playing host to Linux containers on this machine right now. You can hardly see it or hardly tell it, but there is monitorable Linux daemons running on this Windows 10 system right now, believe it or not. How would you see them? How would you monitor them? Well, you bring up a terminal, and for me, this terminal icon brings up Ubuntu 18.04 in full screen mode. You can tell because the requesters have tildes in them and $signs in them. So if you're looking at a prompt and it has backslashes and greater than symbols, you're in DOS or PowerShell. So this is actually Linux right here. What's further, it's in a Python 3.10 virtual environment, a VENV within that Linux. So I know what Python version I'm running. So on my 7 virtual desktops, desktop 4 is a full screen Linux terminal. You can do lsb underscore release -- all to see the details of it. Just to prove to you that this is in fact the environment that I was saying, Ubuntu 18.04. Now this Ubuntu is under Windows Subsystem for Linux and is running a piece of software called LXD, which allows it to play host to other Linux containers. We can list those Linux containers with LXD list, or alternatively just ls, and then the -- fast parameter in order to make it stay on the screen. Oh, I did that wrong. So just to specify what happened here, LXD is the overall package that gets installed, but the commands end up being LXC commands, not D. So it's LXD that's running to host Linux containers here, and LXD's API, Application Program Interface, is all through the LXC program. So here are the 2 containers running on this machine, Munchkin and Winky, named after 2 of the 4 lands of Oz in the Wizard of Oz book series. And Winky is running and Munchkin is stopped. And yesterday I moved over some scheduling services from Munchkin to Winky. I did that by putting all the required files into a GitHub repository, pushing it up from Munchkin, and then cloning it down on GitHub. And I can ls in this directory. Oh, that's the parent directory, so that's not actually true. I can go into the Winky container and ls. You can see this is all my repos that I keep on the host machine, and I'm trying to get into the habit now of really isolating my work and working maybe on one repo or another. So all the dependencies that I pip install, usually I stick into one virtual environment. So to get inside of Winky and to show you a different GitHub subfolder, I can lxc execute, because exec means execute on one of my containers. I name the container, in this case it's Winky. Command line completion works. -- space is how you start to delineate the command that you're about to execute, and the command I'm about to execute is switch user. Otherwise I would be logging in to Winky as root, and that cursor here, instead of a $sign, which indicates normal user privileges, becomes a hash mark or a pound or a tic-tac-toe symbol, which indicates root. So I can actually show that to you. If I just execute on Winky, oh, this is interesting. What do you execute if you're going to just log in as root? Well, you're running a program called bash, which happens to be in a bin folder. So to make sure you get it right, you can do bin and then sh, which is the shell executor. It's almost bash, but it's more like standard Linux shell, which is all you need in order to get in as root. So this little $sign here, no, that's not a $sign. This little hash symbol here tells me I'm logged into something as root. That's not what I want, because it doesn't give me my Ubuntu user context. You want to be the Ubuntu user. So instead of that command that executes bin sh, we are going to execute switch user. And we use the login parameter. Which user are we going to be? We're going to be user Ubuntu. So now instead of root, we're Ubuntu at Winky, and that's exactly what we want. I can do an ls there. You can see I've got 3 directories. This is very typical on the containers I'm doing. My data folder, which you can see is green, highlighted special, is a symbolic link from Linux host machines so that I can move files around. I put things inside of data here because it's in common to the container, the Linux host to the container, and even on the Windows side, I've got this data folder mounted. It exists on my network, so I can even have other machines in my internal network here in my house have the data drive, and I share things between them that way. But we want to go into GitHub, and you can see when I ls inside of GitHub, there's one folder called scheduler. We're going to cd into scheduler, and here are the files that we've been working on for the past few days. And it has everything in here necessary to make this app run, right? So it emails cats once a day. At a certain time today, I'm going to be getting another copy of some cats that don't exist sent to me. These are the 2 files I moved over from the data drive, which are my email authentication things, the things that don't end up in the repo. My gratuitous logo that I put inside of the email that gets sent by this scheduler. I'll probably end up removing that. It makes the whole thing much bigger than it needs to be, and it was a precursor to doing zipped files in there. But it was to see that I could put embedded images in an email, in a HTML formatted email, which is constantly being sent to me now by this scheduler task that's being run, because this scheduler service is in a different location on this system. So now when we're inside Winky, we can see that the scheduler is being run by, I guess, well, we can see that the scheduler exists by going into cd/etc/systemd. If there's one lesson of my videos lately, is that there's this magic directory called etc systemd system. And inside of there, you've got these .service files. Again, these ones are highlighted in a special color. But this one that we're working on is plain old white, which means the file actually exists there as a plain file. If we were to ls-la in there, you'll see that the blue ones are in fact links to things that live in other places. You can see even where they keep it. They keep it in lib systemd system network service. So clearly there's a place lib systemd system that keeps things that are not active or are disabled. You know, they are not enabled. And when they get disabled, they probably remove the link from them being in here to remove any chance of them even being accidentally run. Then there's these .once files. They're not really files, they're all directories. Everything with a .once at the end. And I'll research those more, what they mean, but those are all directories. The one we're interested in is the one we actually put there. And you can look at that with Vim. Now you'd have to sudo Vim if you wanted to actually edit it, but I'm not interested in editing it. And this is simply a file this big. This is what defines a service that is running. So when this system reboots, or when this container is restarted, this is actually run automatically. This line here says, run the program called screen. This is GNU screen. And name that screen Huey. And in that Huey screen, when it runs, essentially the startup script is a reference to Huey's consumer.py file in its absolute path location. and this is an absolute path location, typical and indicative of using virtual env or venv. This is a directory that we've created to isolate the Python dependencies, and it's the consumer, HUI consumer is loading scheduler.py, which has to be referred to here as scheduler.hui because of the conventions of the system. And it works because it's CD'd into that location here. This working directory essentially makes the service run as if it's CD'd into the actual GitHub scheduler location, see? And it's running in forking mode, which has to be used whenever you're using screen. In development, I switch this back and forth between simple mode before screen is being used and forking mode when screen is being used. So now that screen is being used to run the service, it's monitorable. So I'm going to quit out of this. Now you can see at least on this Windows system, yes, I'm playing host to, on this Windows system, I'm playing host to Linux. That's pretty clear. And it comes up fast. If I go to screen 5 and just double click that icon, there's no Linux boot. It just comes up as if you're bringing up a terminal. And this thing here, Windows Terminal, by the way, if I hit F11 to bring back the tabs, it's the unified Windows Terminal. I can pull up all kinds of different things in there. In fact, I have 2 Ubuntus on here. I'm going to have to look into that, but this is the main default one. And, oh yeah, that's right, because oh yeah, okay, I'll cover that later. But it could be a command prompt here or an old DOS window. There's those backslashes and the pointy brackets that are indicative of being inside of DOS or the other main option here, which is PowerShell. And so all these old text interfaces from Microsoft come up under the same unified Windows Terminal program here as I'm using, everywhere else for just plain Unix or Linux in full screen mode, so that you can't see the tabs and stuff. So that's what's going on there. You can exit out. You'd have to exit out of every one of these tabs if you did it this way. That's a fine way to do it, but you could always just X in the upper right, and it would have much the same effect. But it would give you a warning before it closed out. Okay, so let's monitor that service. I told you we're playing host to Linux, that's clear enough, but we're also playing host to a Linux container that is running a service. So here we are in the Linux container, right? Ubuntu at Winky. You can always tell by the prompt where you are, so long as you're not root. Root apparently doesn't need written out prompt. So once again, we open this one, and you can see the prompt is actually different. We're in Python virtual, well, we're not in it. So this one, the Linux host is Lunderwand. Lunderwand is what's being run directly under the Windows subsystem for Linux. Under that, are 2 containers. One container is running. We are logged into the running container here, see? Winky. We're logged into the Winky container. And I showed you where the system was being held. It's in here. But now we can check whether it's being run by typing systemctl scheduler or status scheduler. Oh, disabled. Loaded. Oh, vendor present enabled. Service disabled, vendor present enabled. That's interesting. I'm pretty sure this is running. I need to learn to read these. Oh, there it is, active running. There, I need to read these things better. So it is running. They color code it green for your convenience. I guess pay attention to the color coding. And when you're in one of these things, it doesn't seem like you can get out. Try hitting the Q key. Everything follows the API generally laid out by VI and VIM. So H, J, K, and L help you scroll around. I guess up and down is what J and K. J and K scroll you up and down when these things are long. So if you wanted to see all services, you could just type systemctl on its own. Here's all the services. Q would get you out, but J will scroll you down. And K will scroll you up. And you can find things with slash, just like in Vim. So this is scheduler, and it jumps you right to scheduler service. It puts it to the top. It says it's loaded. It says it's active and running. It even has how I described it in the .service file. So to get out of this, Q, okay, Control L to clear. I'm trying to get that habit into me more than typing clear, except for you users out there, it might be nice to see me type clear. Okay, finally to monitor the service. These services seem to be running invisibly in the background. But as I keep telling you, I'm using this screen program, which you can do screen -ls, -ls as opposed to LXC ls, but this is screen -ls, and it tells you there is a screen on this location named Huey, and you can attach to it by typing screen -r for reattach, but lowercase r is will not create a new one if it doesn't exist, because we're logging into one for a service. If I were creating a new one and I wanted to make it exist, if it didn't, I would use uppercase R, but screen lowercase r Huey, and now we can monitor the service. I'm going to make that look a little better by Control A-D to get out of screen, Control- to get a nice better size here, and then just go back into screen Huey, and you can get a slightly visually better view of the service running. Now finally, for the point of this video, in my mind, I mean, this might have given you a lot of value by here, but what I'm going to do, and there you could see every minute it does that output, and it's way too ugly. Who can look at this, right? Here are the ones I'm generating, but you can see these other ones it's generating is clearly coming from a logging system. So I know that because this is a date time stamp, very typical in logging systems. And then I have info : and then names of stuff, including IDs. So every scheduled event seems to have its own ID. Every minute pulse that I've scheduled, pulse with an ID of that task event. Whoops. And there's way too much information. I want it to look pretty. So one thing you should, and I have kept this running for a long time. I've been curious about how much it runs like a server even when my laptop is closed. So if you were to exit out of this, Control A-D to get out of screen, and then exit out of this, and then exit out of this, that's still running in the background. That is not gone. That container is still there. Winky has not gone away. It's still running. It's still in the background. And just because you can't see it, even if I close this one, we're now back to where we were. 7 virtual desktops, nothing running on any of them. But this is still a Windows 10 system playing host to Linux, which is still running. And that Linux is playing host to Linux containers, or one of which is still running. So we get into it by opening a terminal, getting into the particular LXD instance with LXC exec against Winky, switch user, login, Ubuntu, right? Screen, reattach, Huey. It's going to be a very common thing for me to do. I'm going to be working this way all the time. This is a major shift in the way I work. I spent quite a bit of time to having these abilities so naturally and casually. This is the next phase of my professional and in some ways even personal development. There's no place like home, and home is wherever you decide it is. So home is now these ad hoc, temporarily set up containers, Linux containers, running Linux schedules that I have an easy time now, an increasingly easy time controlling. So let's make this prettier. One thing I need to show you is if you Control C out instead of Control AD, so I can do Control AD and that detaches cleanly. It tells you it detached. But if you're in there and then you Control C, you are not detaching, you are terminating the screen. But being a service as it is, it's going to come back immediately. And when it comes back, you're going to see the start of the service right there. Right? So this is just a much shorter screen because all this gobbledygook got put up there. One of the scheduled events that I create gets put up there. Oh, you're not even right away. The first minute has to transpire before the first pulse comes. That is just a print statement at the top of scheduler.py that is not scheduled. I think every minute from Huey. No, that's one of the pulse ones. That actually is, in fact, you can tell because I put a counter in before my date stamp. So let's get rid of all this gobbledygook finally, right? So I go to screen 3, which is where I very typically keep a browser. I bring up Microsoft Edge, which is my default browser, and I will Google Huey logging. Consuming tasks. We're at the top of the page about consuming tasks. This is going to talk about logging in here. Yeah. There is another way to run your consumer process, Supervisor D. So what I'm doing with screen might have a more formal way under System D. Oh, by the way, we can see that it got up to the point where it sent an email, right? So every time I restart this thing, it creates a new scheduled event a minute from when I restarted it for sending the email. So there's that first timestamp that I told you about. And here's the sending email, the first full minute after the restart. And this is the printed line and it scrolled off. So if you want to scroll up and you're monitoring, Control A, escape, puts you into copy mode. And then that same J and K key that let you scroll up and down in other software, let you scroll up and down here in the screen interface too. So I grew accustomed to this GNU screen program over the years because it lets me do this. Hitting the escape key gets you out of copy mode, so Control AD detaches you from the screen again. It appears though that Supervisor D might be a way under System D in order to do much the same things as what I'm doing with screen, and I'm going to have to look at that. One of my to-do items is to understand Supervisor D. But that's not what we're here for right now. We're here for looking at what the arguments of Huey consumer are. So you can see here's a line Huey consumer, just like the way my script has a Huey consumer line that only lasts to that point there. And then it makes reference to the .py file, but uses a .huey extension. And then you can specify where it puts the log file, but it's not where it puts the log file that I want to change. And that further validates that what it's doing is producing a log file as it goes. I want to make the log file less chatty so I don't have to look at it so much. And here is that -log L option to change where it goes. You can also change the warn level. So one thing I can do is to just change the warn level because that's one of the features of using a real logger as opposed to just open file with a write the way I'm doing my ad hoc one. There's also, they're telling you have to use log rotate, so it doesn't rotate its own logs. This is a future video because rotating log files is one of those fundamental things, and there's an external tool called log rotate. I believe it's standard Unix/Linux that's under, because rotating log files is such a common task. And we'll cover that in a coming video. But really, I just want to quiet the output, right? See how noisy the output is here? Let's quiet that output with the -q argument that gets put at the end of the call, like this. So for people who are not into these arguments, there's usually two versions, a long version that uses 2 minuses and a explicit name. You can see here, -l is the same thing as -- log file. So this is the short version, and this is the long version. So you can use either at the end of a command, and the one I'm going to use, I guess to remind me what it is, I'll use the longer version, -- quiet. So we go over here, Control-A-D to get out, to detach from the service, CD into the magic location, etc, systemd, system. Now we can sudo vim scheduler.service, which is in that directory. Now we can go to the command. I will set wrapping on, set wrap. So when I make this line longer, it'll wrap around. I guess I could alternatively just make it smaller, so I didn't need to turn line wrapping on. I go to the end of the line, and I do -- quiet. I save, I write, and I quit from Vim. And now that I changed a .service file, you can't simply stop and start the service. It'll warn you. It'll say something has changed in that service file. Let me show you. Let me try doing a sudo systemctl restart scheduler. One would think you just restart the service after making a change, but it says warning, the unit file. So I guess .service, the syntax for what one of these things are, is actually a unit file. And it knows that the unit file has changed. It's changed on disk. It knows that. And it even tells you the command to do. Run systemctl daemon reload. So it's a hard command to remember. Daemon reload, all that weird spelling. Is it reload versus restart and all that? But they tell you what to run when you try and do it. So I guess you have to Control-C out of that attempt. But now I have that in my copy buffer, though that is something you need to sudo. Okay, and so now I've reloaded all the daemons, and does it start? Does it start automatically? Well, maybe. Let's try going right into the screen and seeing if it's there. There is no screen matching it. So now that we have, reloaded our daemons, we can start the scheduler. See if it likes that. It's not coming back. It's going to make me do a Control-C. That is unusual. I'm quite disappointed, but we can do screen ls to see if the screen is there. No, it's not. So did the -- quiet at the end, did I spell it wrong? Vim scheduler.service, QUIET. The web instructions. There is quiet, right? And that gets used as a command line argument the same exact way log file does, which they're showing in their example being used at the end of a command to run the program. Even though this log file one supports an additional argument on the parameter. See, this is a parameter, and then this is an argument to the parameter. We're not doing that with quiet. It should just be QUIET. So that all looks correct. So we can check its status. You don't need to do a sudo in front of systemctl. Oh, you don't have to do a sudo in front of systemctl when you check the status of a service. Oh, active and running. Look at that. That's nice. So maybe screen is there now after all. There There it is. It just took a little while to start. So I guess you got to give it time, but we're going to have a after. We did our before, all those times attaching to those screens with all that noisy output. It should be less noisy. Screen reattach, Huey. And there it is, just the 2 custom logging entries that I have made. Much easier to read. Now let's continue to make it even prettier. There's sometimes major events in the running of these things that you want to be able to visually spot much faster, like picking out the email sent from amongst the log file entries. And this is also rather interesting in that it's mixing the output from various things. So these 3 lines are output from the service, the scheduler.py service that's being run by scheduler, the scheduler.py service that's being run by scheduler.service. But these 2 lines are coming from sendcats. So this is mixing the output of 2 different programs. And again, just to remind you, even when we keep screen open like that for monitoring purposes, much of the point is to be able to still get into that machine anyway and monitor and work. So LXC, EXEC, Winky, --, switch user, login, Ubuntu. And so now we're back in that machine, but we're also monitoring it here. So I can go into CD, GitHub, scheduler, and then I can Vim, I can ls in there, ls-la to show you all the files in there and show you that inside of scheduler.py, Vim scheduler.py, there is no reference to email sent. If I look for email, sending email is in here. So I'm correcting myself a little bit. Sending email is in scheduler.py. See, scheduler.py, sending email. But this other line, email sent, is not located in here. Pattern not found, email sent. So I'll quit out of Vim, and then I'll look in sendcats, Vim sendcats. Again, we're looking for email sent / email sent, and there it is, right? So if it's successful sending the email with this line here, it will continue to this line here that says print email sent. So this line is coming from scheduler.py, and then this line is coming from sendcats. Now I might work in where these things are sent from so that when I'm looking at a log file, I can tell what sent what. I'm essentially mixing the output, the program output, from the scheduler and the programs being scheduled. And then I can write all this to a file as well. So this gives me a wonderful way to have a log file that is 100% under my control. There's a log file system already in there by Huey, but I am foregoing it. I'm ignoring it in place of a log file system that I'm sort of cobbling together myself to establish what I really want, to establish 100% control. And then I can maybe move it back to the built-in Huey log file system for whatever added advantages that might provide, like warn levels. And of course, I'll turn this pulse from 1 minute back to like every hour or so, maybe every 6 hours. And yeah, so scheduling systems are nice to have pulses so that you can tell they're still running, and even a counter to show how many times it pulsed since it started. All right, make it prettier, right? Beating around the bush too much here, Mike. So we quit out of here, and we are in Winky, it's important to know that because things that can run are different based on whether you're in a container. Like, things have to be there, right? The fact that I can run Git is only because I apt installed Git at some point, because these containers don't even come with Git. And I'm willing to bet if they didn't come with Git, they didn't come with Figlet. Figlet command not found. Apt install. Well, sudo apt get update. It's just good habit. No matter how many times you've done it recently, it's always good to do a sudo apt update before doing a sudo apt install. See, I was working on this just yesterday, and all packages are up to date, but there's definitely been updates of things in the database. So it's nice to do this beforehand, because if you're going to fetch packages, you want to fetch the most recent version of a package. I was bit by that the other day because I saw all packages up to date, and then I was like, oh, so then I don't have to do a sudo apt update beforehand, tomorrow or whatever. All apps are up to date, but it turns out I got too old of a version of the GNU utilities that are common to a lot of installs, things that enables the compile process. Well, anyway, I'm rambling a bit. And that was the rambling precursor to sudo apt install Figlet. This is high on my list of things that just should always be on a system. Oh, there's an auto update mode. And update alternatives using this to provide this in auto update in auto mode. Maybe that's not auto update, but it's just auto mode. But now we have Figlet. I don't know if I've ever run Figlet just on its own. I'm going to Control C that. I don't like the time it's taking. I'm also going to clear. I'm going to do Figlet hello world. This is the purpose of Figlet, right? That looks pretty, doesn't it? So let's replace something in the scheduler with using Figlet. Now, there's a lot of command line arguments to Figlet, and we can probably see them with --help, and I'm going to proactively pump that into the less program so that I can scroll up and down on it. No, it doesn't have help built in. That is surprising. Oh, well, there's the help. It just didn't. Okay, I guess I didn't need to pump it to less. Well, whatever. We can see the help. And there's -font file, smush mode, output with, control file, and so there's a lot more in there than it's telling you here. And I believe it's -t I want to get the right spacing. So Figlet help one more time. Okay, it's just that. Oh. Okay, so I might Google a little bit about Figlet to get the parameter that I like to use a lot. But we're going to just vim scheduler.py. Well, I have Figlet now from the command line, but this is a very, very Python-oriented script, and any use of Figlet will probably be under the Python context. And it seems a bit overkill to run a Figlet thing under the Linux context, which would require a whole set of things like this to just get Figlet running, which is too much overhead. So you can get much the same advantage of Figlet natively in Python. So I'm going back to a standard web browser here to show you the one I use. Now there is PyFiglet, but I have had a lot of problems with PyFiglet, and I have been much more inclined to use a program called Art. So if we pip install Art on a search, it will bring us to the Art page of Python packaging index, pypy.org. So this is where all pip installable software comes from. If you're not running your own, pip server for internal company use, when you're just using pip normally, it gets pulled out of this repo. And this is a larger package that lets you do all kinds of ASCII art stuff. But one of the things it lets you do is this same Figlet thing that I'm doing right here. And this is one of the reasons why I keep Jupyter loaded. Now it's not loaded right now because I was showing you starting my system very much clean and from scratch. But I run Jupyter here. Takes a moment to load. And after you double click or use the keyboard shortcut, you shouldn't surf away because it's going to end up on whatever screen is showing virtual desktop wise when it finally loads. So I stay on screen 2 long enough for that to occur. But you know what? While that's going on, I'll go to screen 1 and bring up a terminal there because I am almost never not running my journal to talk about the things I'm doing and to document them as I go. So while that's loading, I'll load the terminal here. Well, that's taking a little while, so I go back over here. I bring up a new notebook. Now I did that in root of my GitHub. I hate doing that. I didn't mean to do that. Discard that work. I'll have to delete that at some point. But I almost always go into a directory called practice. One of my practice directories. I often have multiple practice directories. And I'm not even in GitHub yet. That's my native Windows Home location. So one click to go into the GitHub repo, which I do even on the Windows side, as you can see. Another click will bring me into my practice directory. I guess I'm on practice 3 right now. And now when I open a, is that it? Yeah, I've been doing a lot of files in there lately. Once in there, I can open this, and so now I'm in a notebook that just gives me all these sort of ad hoc capabilities. So I can try importing art, import art, to see if I have pip installed that here yet. So I haven't. So you can pip install art. This is a one-time thing. You don't have to do that more than once, but this is how you cut your teeth on a package you haven't used yet, right? It's fun to do in Jupyter in this interactive calculator type mode. Now you can even just get rid of that. It only had to be done once under Jupyter. It's installed. Now you can import art. And now you can use art dot. And while it's not blazingly fast, it's not as twinkly awesome as the built-in IntelliSense of say VS Code. You do have completion here, and you can look up and down at the built-in things within a package that you just imported. I happen to know it's text to art that I want to use. I know that because I was looking carefully on here as it was going. And now they're just putting text to art like that, except they did it because probably their import shortened the reference to it. And I'll show you that in a second too, because I like to do that. And I'm not going to be using art for anything other than Figlet. But the hello world that we did, see, look at that. So to make it look correct, we might have to put a print around it. Yeah, print did it. So there is hello world as shown in Figlet under the art package. under Python, under Jupyter Desktop. And you can kind of imagine the utility here in log file creation. So we're going to put just starting, the word started, start just at the top of our, we're going to be replacing this with a Figlet. So let's get to it. Control AD to detach. Didn't really need to do that because I'm also logged in over there. But no, I'll just keep it running. There's no harm in showing that it's a before and after, right? So here we are going to import, it's text to art, I believe. Text to art. Text to art from art. Now chances are that is not on the machine yet, so we are going to make sure we're in the virtual env. Remember, even on my containers, I'm using a virtual env, but I'm not bothering to activate it every time I log in. Now I could do that. There's very little harm in activating it so on login. So let me do that as a bonus first so that you know the command is source and then just reaching into a location that you know exists, pi310 bin to a script that you know exists, activate, right? So here we are having activated our virtual env, which is something we need to do before doing a pip install because of the context which the service is running under. But remembering to do that all the time can be a royal pain. So we can deactivate, and then we can cd to home, and then we can ls-la for a before. There is not a file called bash profile. We can make a file called bash profile by saying vim.bash profile. In that file, we can insert that activate command, save and quit, exit out of Winky, clear, do the command to log back into Winky, and here we are under an activated virtual environment. We lost color coding. We can get that back too. If I do an ls-la, we don't have bash prompt here. I'll do an add. I'm going all the way. Why don't I color code the prompt? So one of the things that I keep in data, ls-la/ls-la/data, one of the things I keep in this location, you can see I'm moving my Camtasia programs around and stuff between machines, but one of the things I'm keeping here is bash prompt. That is not bash profile, which I just did. This is bash prompt. So I can cp bash prompt to my current location. Not, yeah, cd bash dot, yeah, I got that right. Oh, no such drag, okay. Bash dot prompt, something looks wrong in my, how I'm doing this. cp ~/data bash _ prompt to my current location. Okay, it doesn't like something that I'm, oh yeah, I'm leaving the dot out. It's an invisible file. Okay, so now we have the file I just created, bash profile, but we also have bash prompt. Now I'm using bash prompt in my Linux host machine to give me that wonderful color coding. So to remember how to activate it, I'm going into my Linux host machine under a different terminal. So just to give you a refresher, we've got 3 terminals open, 2 to Winky, 1 to Lunderwand. And in Lunderwand, I can just view, so vim, my home.bash profile to see how I call bash prompt. It's with a command that looks like this. This is why I look. It's not very usual dot space tilde forward slash bash prompt. I take that command, I vim the bash profile on Winky, and I make that the last thing activated. That means it happens after we source activate the virtual env. Now we bash prompt, we write, we quit, we exit all the way out of Winky. See, we're back in Lundervond. We go back into Winky, and now we have the wonderful same color coding as we do in Lundervond. In fact, if I cd into GitHub, you'll see the color coding right down to here. I can probably cd into Scheduler, and it tells me even the branch I'm on in different color coding. So I'm in the main branch. So I'm in, this blue is the virtual env of Python 3.10. The green is the user at host name from the container, username from the Linux container under this host, and then your path, and then your GitHub repo branch. It's in purple. So isn't that wonderful? It's a wonderful way to know where you are and make it all look pretty. But what we're really going to do now is edit the file to use that text to art, was it? Anyway, it's inside this directory. The file we're going to edit, it's scheduler, so vim scheduler.py. And now this import text to art from art is going to be active, and there's a print line that I do at the beginning of scheduling when this runs. Oh, there it is. The Pulse service has started using Huey. And you can see that over here. The Pulse service has started using Huey. We're replacing that with Figlet, and maybe even eventually the sending email, so that as you scroll up and down, these things are easy to spot. So I don't believe we need to wrap it in a print statement. That is because the native output display of Jupyter is proportional and gets rid of white space on stuff. So it is possible to just put this line by itself. In fact, all I would really need is this because of the way the import worked. So I take this, which I experimented here in Jupyter. I place it over here. And we should have a hello world instead of this. And we should get that with just a Control-C restart to exit out of the service. Screen is terminating, but the screen that terminated was a service which pops right back. If I didn't create a syntax error in there, and I probably did. So if it's not coming back right away, you created a syntax error. Oh, I did not pip install art. So it's the syntax error is because, you know, art is not pre-installed here. So watch this. This is a nice before and after. Here are the attempts to run screen with a package missing. There's no output, or if there is from systemd, you'd have to go look in the systemd logs to find the error output. You could do a shortcut and just type systemctl, and you can actually find scheduler because it's stuck in a busy loop trying to activate every 5 seconds, loaded and activating. If it's set on activating and it's auto restarting, you got a syntax error. If it's running correctly, it's just going to be active and running, right? This is the signature you're looking for. So we quit out of here, and we are under the virtual environment now every time we connect into Huey, right? Exit. We're back in Lundervond. Now we're in the container again, virtual environment activated. And, you know, you can even see that the tilde is yellow to show you your path. This is really wonderful. I love this way of working. This is about making things pretty. so that they're love-worthy. You make them pretty, they become love-worthy. You do them more often, right? Maybe making your work love-worthy, making your Linux service scheduling work love-worthy might be the point of this video. But anyway, I can now pip install, right? I can pip install because we can see we're in the virtual environment where I'm containing all my dependencies. So pip install art. And because the service is attempting to restart, it's not, the screen is not there, screen is not there, screen is not there, but the dependency has now been met, and every 5 seconds the service is trying to restart. And I didn't change anything in the .service file, so there's a very good chance I just get it right. Maybe not. Oh, I was hoping that was going to be a glorious demonstration. So maybe I do have to restart the service. That'd be sudo systemctl restart scheduler. Oh, I'm going to have to get better at this step. Still having syntax wrong. That's been 3 seconds. If it were correct, it would have worked. So to check if it's working, we can stop it because, you know, I don't like it being stuck in this kind of busy loop. So we make sure it's explicitly stopped. We look at the command it's trying to run by vimming scheduler.service. We can take that whole command here, from here to here. That whole thing should just work. Even under the context of the virtual UNIV, I shouldn't have to deactivate that, but we just paste that over here, and then we check for screen again. I guess I'll do that over here. Still not showing? Okay, fine. We can run it without being funneled through screen by taking this part out of it. No module named scheduler. So for testing it here, we do need to be CD'd into the right location. CD GitHub scheduler, clear. Now running that same command with the screen stuff chopped off. Import text art, import from art. I just got my syntax wrong on the import. All that because, boom, syntax error. So let's do a good, glorious before and after. Clear, screen, -ls, no sockets found. Every 5 seconds, it's trying to reload that service. Every 5 seconds, this syntax error is being generated. It's probably being logged somewhere by systemd, and I'm going to have to look into that. But all I have to do is now vim scheduler.py, fix my import from art. Yeah, no, from art, import text to art, like that. Save. And like I thought, there's no service restart that's necessary. It's just after 5 seconds of getting the syntax right, the service should reappear. Did I get that wrong still? From art, import text to art. All right. Just grabbing for the brass ring didn't do it. Let me use this parent here to again log into Munchkin. So then I'll have 3 things to Munchkin. The place where I'm attempting to run the service, the place where I'm editing the files that constitute the service, and a place where I can test run it outside the context of a service. So lxc exec winky su login Ubuntu. I've got to turn something like that into a shortcut, but if I do, I have to parameterize which container I'm logging into. So it'd be something just like, you know, LU Winky or something, but we'll get to that later. And now I can execute that command. Is it in my copy buffer still? Yeah, it is. I get rid of the portions that are for creating a screen named Huey, and I try running that. No module. Oh, and I have to cd into GitHub, scheduler, clear, run that command again. Oh, look at that. It is in fact running. So maybe what I'm discovering, I'm going to Control C out of that immediately. And maybe what I'm discovering is that when you edit a PY file, you do have to restart the service, I suppose. So sudo systemctl restart scheduler. It restarted. And there we are, finally. So even when you edit a .py file, you definitely do have to restart the service. These are the things one has to internalize in this kind of process, in this kind of workflow. So we're not using slick graphical user interface software here. This is the point. We're just doing system administration like ye old sysadmins. But it's now within the reach of the average everyday person on a Windows 10 system, using Linux containers, using services, Linux services under those Linux containers. Screen reattach to Huey. Oh, no Figlet, right? This should be some nice output here. And I should have been able to tell that from here when I tried running it directly. There should be some Figlet output there. Why isn't there? From art, import text to art. Text to art, hello world. Let's try putting a print there. Maybe the print is necessary. And remember, a simple print statement puts it out to the command line. That should be enough, right? Because there's that print, this other stuff, it went out to the command line, it went out to the console. Some people call it the console when you're running software and you're watching the output that streams to the console from the running software. So I put a print in there, and we do a test run here, and there's our hello world. It does need a print statement around it. So Control C, restart the service, connect into the service. There's our hello world on the service. Now there's going to be an email. The email event will be among a bunch of pulses, and it might be nice to have the email event also have a Figlet. So I'll let this continue to run, so that'll be our before, but now we have our exact pattern, right? It's this for our import, vim sendcats, there's our art import, and it's now one thing that you can do is you can rename stuff. Text to art is kind of hard for me to remember, so I can do as fig. So I rename the import. I rename the function on the import. So a print wrapped with fig will do that nice big hello world stuff. So email sent is what it should definitely be. So I can just wrap, see those spaces in there? You can see at the time I copied this from internet code, it was probably Python 2.x, and I just threw the parentheses in to make it work and forgot to take the spaces out. I should run the black uncompromising code format or linter on this, but we'll get to that in a different video. All I have to do is put fig there for email sent, and it will have a nicer output. I think it should be a capital email and an exclamation point for excitement. So there will be an email sent here because enough time has gone by. Sending email might be nice to put in Figlet as well, but for demonstration purposes, I'm going to put email sent, which is coming from the external program, right? This is coming from sendcats. So Control C, 2 Control C's, and now my perception that you did not have to do a reload comes from the fact that if it's being referred to through the run command, it's being loaded externally. And when it's being loaded externally, it is being loaded off the hard drive every time and not memory. So you will notice that even though when I change schedule.py, so when you change the schedule, you have to restart the service. You changed the schedule, you have to restart the service. Any edits of schedule.py requires a systemctl restart. Now, as you will hopefully see within a minute, because it's scheduled to happen within a minute of this script running. It was within 5 seconds when it was under pip install schedule, but now that it's under pip install HUI, the most precise exact scheduling under the periodic system that they use is down to the minute, not down to the second. I might look into that. Sending email. If this comes up under Figlet, I do not have mud in my face. Email sent should be in that same glorious Figlet-sized ASCII art as Hello World. And if it is, bam! Look at how much prettier this is than the HUI log format output that I quieted that you saw at the beginning of the video. Now that definitely needs a capital S in email send, but I don't need to make you wait for that. But I can do a git commit. I'll do a git status so that you can see the files that I've changed. I've modified these 2 files, and the swap file is because I'm editing Vim. It's because Vim is loaded there. Watch, if I quit out of Vim and I do a git status, now it's just these 2 files and not the .swap file. But if I never want to look at that .swap file thing, you can just vim.gitignore, and you can put everything that has a .swap file extension in here. And so even if you have something loaded in Vim and you do a git status, it will not show the swap file. But it does know that I modified gitignore now. Git commit, added Figlet. Git push. Now you can get my work. You can get a copy of that work over at GitHub, right? Did that really happen? github.com/mclevin/scheduler. Added Figlet. All this work is yours to look at and admire. Wow, what a successful video. Thanks for joining me. Don't forget to subscribe, and don't forget to continue along with me on this Linux adventure. If you're new to this and this is of interest to you, go back 5 or 6 videos, find the beginning of this series, and follow along to where I build up to Linux services under a Linux container, under Windows 10. Pretty cool stuff. Later.